Hello everyone, I hope you are doing well. So in this video, we are going to discuss the first three problems of Codeforces Round 896, which was rated for Division 2. So one more contest added to my list where I couldn't solve problem D, and I believe the problems were not very difficult. So as that, I'm on a perfect streak on not solving D. So anyways, let us quickly discuss the first three problems. So the first problem says that we have been given an array of integers, right? And we have to perform at most 8 operations on it, and we have to make all the numbers equal to 0. So let us understand what are those operations. In one operation, we can select two indices L and R, calculate the bitwise XOR of all the elements in the range L to R, and replace all the values in the range L to R with S, which is the calculated bitwise XOR. Right. So it involves actually three steps. That the first step is to select the range. The second step is to calculate the XOR of the range, and the third step is to replace all the elements in the range with the XOR that is calculated. Now we have to make all the elements 0 in at most 8 operations. Right. So this is our whole problem, and let us see how we can solve it. So the very first thing that I wanted to discuss is that the bits are independent of each other. Right. So now let us say that we have an array. Right. So the current array is of even length. Right. Now let's say I have some ith bit. Right. Now I'm going to perform the first operation as 1 to n. If I perform this operation, there are two types of cases. The number of values which have the ith bit set are even. Right. So the number of values which have the ith bit set are even. Now if this is true, then those even values will form pairs of n by 2 each and will cancel each other out. Right. Now if the ith bit set, if the number of such values is odd, then the whole array from 1 to n will have the ith bit set. Now in this particular case, the ith bit in the whole array has become 0, and in this case the ith bit in the whole array has become 1. So if the ith bit is 1 in the whole array, then we can perform the same operation one more time, and now I know for sure that the number of values with the ith bit set are even, because the size of the array that we considered was even. So the number of such values whose ith bit was set has become even, and now I can apply the same operation to make all of them 0. So if the size of the array is even, we can perform this particular operation 1 comma n 2 times. If we do this, all the values will become 0. Now what if the size n is itself odd? Now in this case, if we perform the same operation on the range 1 to n, now the first case will still remain the same. If the ith bit set, if the number of such values is even, then my ith bit is going to be 0 in the whole array. Now again, if the ith bit set is odd, then my ith bit is going to be 1 in my whole array. Now even if I perform this operation 1 to n once more, the number of values with the ith bit set will still be odd and they will not be able to cancel each other out. But what if I perform this operation on 1 to n minus 1? Right. If n is odd, then n minus 1 is definitely going to be even. So if I perform this operation 1 to n minus 1, all of the values inside this range will become 0. So now let's say the array is something like this, 0, 0, 0, 1. Right. So now in this particular number, the 0th bit is set and all these values have become 0. Right. So now what I can do, I can perform an operation on n minus 1 comma n. So if I perform this operation, all of the bits from here will be copied to this particular number. So this will become 1 comma 1 and the final operation will be n comma n. So if I perform this operation, these two values are exactly similar. So they both are going to be 0 now. Right. So these are the two cases that we needed to think of. In the first case, if n is even, this can be one of the possible answers, 1 comma n, 1 comma n. And if the value of n is odd, the first operation will still be 1 comma n. But next we have to perform an operation of 1 comma n minus 1, then n minus 1 comma n, then the final operation n minus 1 comma n. So here we took the XOR of the whole array. Now there might be some bits which will be set in this particular case. So I can reset all of them by performing this operation. So all the values from 1 to n minus 1 will become 0. This operation will copy the nth element into the n minus 1th position, and since both of the values are equal, if I take their XOR, both of the values are going to be 0. Right. So this was all about this particular problem. Now let us have a look at the final code. So you see what I've done is I've taken an integer n and I've taken input in the vector v. Now I'm creating a vector pairs of n which is going to be called operations. Right. Now 1 comma n is same in both of the cases, and what I can do, if n is odd, I can push back 1 comma n minus 1 and then n minus 1 comma n and then n minus 1 comma n. So you don't actually need to maintain a vector and push back these values like this. You can just directly print your answer since you already know what is going to be the answer. Otherwise, you can just push 1 comma n into your vector. Now you can print the size of the operations vector and all the values respectively. So this was all about the first problem. Now let us have a look at the second problem. So this problem was 2D traveling, and this said that we have been given n cities, right, and each city is represented by a coordinate system x comma y, right. Now the first k cities are called major cities, and the cost of traveling from one city to other city is defined like this. If the cities I and j are both major cities, the cost will be 0. Otherwise, the cost will be the sum of the absolute difference between their x and y coordinates. So this is how they have defined the cost to travel from one city to another. Now we want to minimize the cost of traveling from city A to city B, right? So in this, for example, this is the value n that has been given to us. This is the value of k, which states that the first k cities are major cities, and this is the value of a and b respectively. So all of these are denoting indexes. Now let us discuss how we can solve this problem. So one thing is for sure, if I am given 2 points, one of the shortest way between them would obviously be a straight line. So the shortest way would be a straight line like this. So now I know that if this is x1 comma y1 and this is x2 comma y2, this is going to be one of my possible answers. Can I improve my answer? This should be my second question. If yes, how can I improve my answer? Now I know that the first k cities that I have, let's say these are those k cities, I can travel between these cities free of cost. So if my source and destination both lies within these cities, I can travel free of cost. So let's say my city A and city B are both out of this network of k cities, right? Now if this A city and B city are out of this network of k cities, there should be some way to enter this network and there should be some way to leave this network. Now, once I enter inside it, I can travel to any city free of cost, and once I leave it, I should be able to reach city B in minimum cost. So now what I can easily do is, I can find the city which is closest to city A, right? So let's say these are 4 cities, 1, 2, 3 and 4, and let's say that this city 3 is closest to A. So I can calculate this distance D3A, right? Now there must be some other city which is closest to city B, right, among these k cities. So let's say this is city 1, right? So I can calculate the distance between city B and 1. So this is going to be D1B, right? If I add both of these values, this is going to be my second candidate for my final answer. So these are the only 2 possibilities that you have for going from city A to city B, right? The first possibility was that you directly go from city A to city B without using anything else, right? So this was the first possible way. Now the other possible way was to utilize this particular network of major cities. To utilize this network, you must first enter this network and then you must leave this network. You would be entering this network from city A, and when you leave, you have to go to city B, right? So in order to enter, obviously you would choose the city which is closest to A. So in this case, let's say it was city 3. So I calculated the distance D3A. And now if I want to leave this particular city, then I would choose the city which is closest to city B. So let's say in this case it was city 1. So I calculate the distance D1B and I add both of the values, and it is one of the candidates for my final answer. If I take the minimum of both of these values, then that would be my final solution, and this is how you had to solve this problem. So now let us have a look at my summation. So you see what I've done is I've taken 4 integers n, k, a and b. I've decremented a and b for 0-based indexing, and now I take a pair of integers as input in the vector b. Now I've initialized my answer with the direct distance between city A and city B. So I'm taking the difference between the first coordinates or the x coordinates, and I'm taking the difference between the y coordinates. Now I initialize this distance dA and dB, which is the nearest city from the network to city A and the nearest city from the network to city B. Now both of them I have initialized with infinity. Now I'm just traversing through all the k cities and I'm just going to find its distance with city A and city B respectively. So I am updating dA as minimum of dA comma its distance with city A. Similarly, I am updating dB as dB comma the current city's distance with city B. Right. Once I have found the correct values of dA and dB, I can update my answer as minimum of answer comma dA plus dB, and that would be my final solution. So let us move on to the next problem. So this problem said that we have been given a matrix and we somehow need to maximize the MEX of the whole matrix, and I will tell you how are they calculating the MEX. So I also got TLE on some test case. I'll also explain you why I got this TLE, and let us have a discussion with the help of an example. So we will be given some values n comma m. So there will be n rows and m columns. Now let's say I have a matrix of size n cross m. Right, let's say like this. Now each of these rows will be a permutation, right? And the values in the permutation will be from 0 to m minus 1, right? So this is a n into m matrix, and each of the rows will have a permutation of values from 0 to m minus 1, right? Now what I'll do, I'll take the MEX of all the values in this particular column. Let's say this is C0, this is C1, this is C2, this is C3. I'm going to take the MEX of all the values in this particular column, and then this particular column, and then the next column, and then the final column. Right. Now once I've got all of these MEXs, I'm going to take again the MEX of C0, C1, C2 and C3. Right. The value that I get after it will be my final answer, and I have to maximize this particular answer. This is my whole problem. Right. So this problem was a bit of observation and pattern finding. So let us discuss this particular test case only. So in this case, you will realize there are 3 and 3, 6 rows and 4 columns. So let me just erase all of this. If there are 4 columns, then the maximum value of m minus 1 will be 3. Right. So let's say this is 0, 1, 2, 3. Then at max, my final answer can be 4. Right, which is effectively equals to the number of columns. So let us see, can we achieve the answer 4 in this case or not? So the total MEX is 4, right? Let's say I want the MEX of this particular column to be 3. How can I make it 3? The values should be 2, 1 and 0. Only then the MEX would be 3. So I am putting all the important values. Now let's say the MEX here should be 2. So the important values here are 1 and 0. If the MEX I want here is 1, then the values I should put here is 0, and if I want the MEX here to be 0, then I am not going to put any value here. So you see, I have stored all the values that are must have in these specific columns for the MEX to be these values respectively. Now I want to fill the columns with the remaining values. So what can I do? Let's say I am talking about this row. I have not even utilized even a single element, so I can put 0 here. Right, I can also put 0 here, I can also put 0 here. So you see, what I am trying to do is, I know that in this row there should be a permutation of from 0 to m minus 1. So I am trying to put the minimum value here. Right, why the minimum value? Because I want to stay away from this particular value 3. Right, this is why I am trying to put the minimum value. Why do I want to stay away from this particular value? Because the MEX is currently 3. Right, I have put the values above it such that the MEX is currently 3. If I place the next value as 3, the MEX is going to become 4, which essentially ruins my initial plan. Right. So what I'll do, I'll try to put the smallest value that I can put here, and I would make sure that it is not equal to the column or the MEX that I want to make here. Right. So let's say now I come at this particular row. The smallest value that I can put here is 1. Right. So I can take 1 here, I can take 1 here, I can take 1 and 1 here. Now I come to this particular column and I check in this row, the smallest value that I can put is 2. So I can put 2 here, I can put 2 here, I can put 2, I can put 2, I can put 2 here. Right, so I have filled all the values with 2. So I can put 3 here, and 3 is same for all the rows. Right. So essentially what I am trying to do is, I know that I am trying to maximize the MEX equals to the number of columns. If I want to do it, I know what are the values that I have to put in the rows initially. Let's say I decided these 3 values initially, I decided these 2 values initially, and I decided this value initially. right? So I marked all the values that should be present so that my MEX becomes this particular value, right? Now I have to put the remaining values such that my initial plan doesn't get ruined, and I am also taking care of the values that have to be put in each of the rows, right? So this is how you just had to put all the values, and this is how you can calculate your final answer. Now the reason why I got TLE was, once I have completed this particular table, I was calculating the MEX of all the rows and all the columns manually by using a set, right? So I was trying to do it by using a set, which is not a good idea because it would take too much time, obviously, because of the login operations. So is there any other way to find the exact answer? Yes, there is. We know that one upper bound on the MEX value is the number of columns, right? What is the other upper bound for the number of rows for the MEX value? The other upper bound is going to be row plus 1, right? So first of all, I'll have to take the minimum of these two values, that is row plus 1 and column, right? Let us understand how the row plus 1 is going to be an upper bound on the MEX value. So let's say we have 2 comma 4. So this is our matrix. So if I draw this particular matrix, let's say I have this 2 rows and 4 columns. So it will look something like this, right? So I want 0 to be here, 1 to be here, 2 to be here, and 3 to be here. So I am using the same logic. I am expecting my MEX to be 4, my maximum MEX to be 4, right? So now I can try putting some values. In this particular column, I want MEX to be 3, so I can put 2 and 1. In this particular column, I am expecting MEX to be 2, so I can put 1 and 0. Right, in this particular column, I am expecting MEX to be 1, so I am putting 0 here, and here I will not put anything. Right, so once I have done this, again the same ideology, I will start from the right, and this is the first empty box that I have encountered. In this particular row, I have put 0 and 1, and the next thing that I can put is 2. In this particular row, I have put 0, 1, 2, so I can only put 3 and 3 here as well. Right, so you will see that I am able to make MEX equals to 0 here. I am able to make MEX is equals to 1 here. I am able to make MEX is equals to 2 here. But for all subsequent rows, my MEX is going to be 0 because there is no 0 present for the MEX to be greater than 0. You will see in this particular column 0 is not there. Even if there was one more column, 0 would not have been there according to the logic that we are following. So the MEX in this case is row plus 1, that is 3. Right, there were 2 rows and the MEX is coming out to be 3, which is the MEX of these 3 values 0, 1 and 2. The final MEX is going to be 3. So this problem was a bit of observation. Now the problem with these observation and pattern finding problems is that you need a way to start the problem, right? So I started this problem in this way. I tried to maximize my MEX equals to the number of columns, and if I wanted to do this, I needed one column with the MEX equals to 3. I needed the other column with the MEX equals to 2, 1 and 0 respectively. Right, so I tried making each of those columns, and I have tried filling the rest of the places with some reasonable values. Right, so this is how you can solve this particular problem. And there is one more very important thing. I believe there was one test case here. So let me just right, so this was the test case 2, 1. So let us discuss this one last test case, which is 2 cross 1. Right, so what happens in this particular test case? There are exactly 2 rows and 1 column. Right, so it is like this. Right, now since there is exactly 1 column, my maximum MEX can be 1. Right, and my number of rows is 2, so by the rows I can make the maximum MEX 3. So I am going to take the minimum of 3 comma 1, which that is 1. Now I would be expecting my MEX to be 1, but that is not the case here. You will see why. So if this is 0, I cannot put any value here, right? I'm not able to put any value here. So in the initial iteration, I was not able to put any of the values, right? So you see, as in these examples, when the column number was 3, I was trying to put all the values from 2, 1 and 0. Now the column number is itself 0, and in both of these cases, I did not put any of the values. So for the initial iteration, we left all the values blank. Now comes the term to fill the remaining values, right? So here you see the smallest value that I can put here is 0, right? But the column number is also 0. So if I put 0 here, then I wanted the MEX of this column to be 0, but it is not going to be 0, it is going to be 1, right? This is exactly what I was trying to avoid here. You see, in these particular rows, I was trying to avoid the column number here. right? So if the column is 3 and I put 3 here, my mx is going to be 4 because the current mx is 3, and if I add 3, the mx is going to be 4. Similarly here, the current mx is already 0. If I add 0 here, the mx of this particular column is going to be 1, right? But in this particular case, I have no other choice than to do it, right? So I'll have to put 0 here as well. So whenever I encounter this particular scenario, my chain of mx will break. Let me just give you one example from here. So let's say in this particular column, the current mx is 2 and I change this value to 2, right? So what will happen now? This whole mx is going to be 3, right? So my values are now going to be 0, 1, 3 and 3. The mx of all of these values is going to be 2. So you see, in the column in which I was not able to put a suitable value, that will be the final mx, because the chain is going to break from that particular column, right? So if the chain breaks, this column itself is going to be my final answer. So we have discussed that the upper bound on the answer is going to be row plus 1 comma column, and if we encounter any situation where we are not able to put our value, the column number is going to be a final answer, right? So this was all about this particular problem. Now I believe I have discussed this problem with all the intuition that I had and all the patterns that you have to observe. So let us have a look at the final code. So you will see what I've done is I've created a double dimensional vector answer of n comma m size, and I've initialized a start vector. So you'll see what this does, and I've also initialized a set called all. So this is going to have all the values from 0 to m minus 1. Now I'm initializing this vector of sets. So this is going to show me what are all the available values in my nth row, right? So all of them are initialized with the set having values 0 to m minus 1. Now I'm creating a reverse for loop and I'm traversing from m minus 1 to 0, right? So my current value is I minus 1. That means I want to start putting values from I minus 1. Now if current is greater than minus 1 and start of I is less than n, that means I'm going to mark my answer of start of I comma I as current. So basically start vector has a size equal to the number of columns, right? So start of I means I is the current column and start of I is denoting the next row in which I have to put my latest value. So this start of I is going to give my current row and this I is going to give my current column. So answer of start of I comma I is going to be my current value. Now since I have put this particular value in this start of I row, that means I cannot use this value further. So I have to erase this particular current value from available of start of I. Since I have covered this particular row, I have to move to the next row for this particular column and I have to decrement my value of current, right? So this way I am going to put all the essential values that I wanted. Now I initialize my value. So this is going to be my final mx by minimum of row plus 1 comma column, right? Now again I'm trying to pull all the values from the reverse, and now I'm going to start my rows from start of j. So now j is the column number and start of j is denoting the next row I have to put my value in. I'm trying to put the smallest value, that is why I'm taking a pointer to the available of the current row dot begin, right? So if this pointer is equal to the column number, then I have to increment my pointer because I cannot take this particular value and the next smaller value that I can take is in the next pointer location. After incrementing this pointer, if it reaches the end of the current available values, that means I cannot find any other suitable value for this particular row, right? So now what I can do is I can decrement my pointer. I'll have to take that value no matter if I want it or not, and I have to set my value. This is going to be my final mx as the column number. So I've already told you why I'm setting the final answer as column number, because taking the value that I didn't want to will break my overall mx chain, right? Now I can set my answer of ij as whatever value is present in this pointer, and I can remove this value from my available list of the current row, right? At the end I can print my value and print all the values of my answer vector. So this was all about this particular problem. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.